Hi, everyone. First of all, thank you so much for being here. I'm Paresh Gupta. I'm a technical marketing engineer in Cisco, and today, for the rest of this hour, I'm going to talk about SAN analytics and SAN insights. Okay, so this is what we are going to do for the rest of this hour. Obviously, I don't want to assume that everybody knows everything, so I'll try to start from basics, but then I don't want to spend too much time in talking about what the product is and like internal details and all that. No, I want to focus more on use cases. For example, when you have this thing working, maybe your colleagues have this working, how you can solve those problems that could not have been solved before, right? And mostly I have real case studies that I've learned from other customers while working with them, right? So hopefully that will make sense to you as well. Okay, so to start with, what exactly is SAN analytics and SAN insights, right? So, I mean, when we look at applications and we think about why applications may slow down or why their performance may get impacted, there could be 100 reasons, right? And when somebody, let's say an application owner, they don't really know much what's happening at the infra layer. For them, it's like compute, it's memory, and it's like a volume or a disk. But let's say if somebody believes an application is going slow because of storage access issues, then what, right? That's all probably people suspect. Sometimes they have data to believe what they think. Sometimes people don't have data to believe what's happening, right? So what SAN analytics does, especially if you have a SAN environment, which is essentially built using MDS switches, and you have external storage arrays, maybe coming from Dell EMC, maybe coming from HP, IBM, Hitachi's, on all the big storage vendors in the world. What SAN analytics does is that as I/O transactions flow over a SAN, the MDS switches do a deep packet inspection all the way up to the headers of fiber channel and SCSI, or it can be NVMe if you have NVMe, and then collect those performance metrics, right? Now, what are those performance metrics? Essentially anything or everything that you have ever heard of that is used to measure the performance of storage. Things like how long your read or write commands take to complete, right? People generally call that as latency. But then latency is a very loose term. We have three different kind of latencies, and I'm going to talk about that in a few minutes. But essentially, we use the word called exchange completion time. It's quite hard to read that, but that's one of the metrics. The other metric is data access latency. That's something really point to how long the storage array is taking to respond, right? Things like how many I/O operations are being finished in a second. Things like what's the throughput, what's the I/O sizes. There's a long list of metrics, and few of them I'm going to cover in a few minutes. But the idea is that when the switches collect these metrics, we know we are not going to solve the problem on the data network layer. So the switches export the metrics to what we call as SAN insights. Now, what is SAN insights? SAN insights is essentially it's an analytics and visualization engine within Nexus Dashboard Fabric Controller. And I'm sure you guys have heard enough. Nexus Dashboard Fabric Controller, or NDFC in short, is the successor of Data Center Network Manager, or DCNM, right? So essentially, SAN insights, as I said, is a visualization and the analytics layer that sits external to the switch. But then just the metrics are not going to help any one of us, right? It's just like a lot of data. So what SAN Insight does, it converts those metrics into use cases. Things like you can detect anomalies with your storage transactions. You can optimize your, let's say, storage allocations. You can detect errors. You can decide that where you should keep one VM versus other, things like that. And I'm going to cover some of the use cases that how exactly do that, right? So that's the short of what SAN Analytics is, right? The switches collect the metrics in line without any performance side effect because of the hardware capability, and then the metrics are exported to SAN Insights. That's where the visualization and the analytics layer comes in play. Okay, now before going forward, just a brief of what exactly the terms are. So essentially, SAN Analytics is the name of the solution, the overall solution. But then we overloaded the term of SAN Analytics, and we said that the feature on the MDS switches that enables collection of performance metrics is called analytics. So there's a command on NXOS that says feature analytics. And after that, the switch enables collection of the metrics. After that, there's an export mechanism that's really streaming telemetry. We call that as SAN telemetry streaming. Some people say it STS. So when somebody says STS or somebody says streaming telemetry, it's one and the same thing. In short, it's an export mechanism. It's an optimized export mechanism. And why do we need this export mechanism? Probably, if you have been to some other sessions, there are a lot of sessions that talk about this. But the amount of data that's being collected by SAN Analytics, any API call or SNMP cannot scale. So we need an optimized way. Really, the transport here is gRPC, and the encoding is protocol buffers. So using that, we are able to export like millions of metrics. To be precise, I think it's 3 million metrics every 30 seconds. And using streaming telemetry, we are able to send that. And finally, the third piece of this solution is SAN Insights, which is an analytics and visualization engine within NDFC. Right? So people may use words like SAN Insights or SAN Analytics. I mean, it doesn't matter. It's like, just focus on what problem it can solve, right? And that's why I'm clarifying, right? Let's not get lost in the names, right? But yeah, there are 3 names: SAN Analytics, the overall solution, and also the feature on the MDS switches, then the export mechanism, and finally SAN Insights, which is the visualization and analytics engine within NDFC. Okay, now quickly talking about the architecture, a lot of times, people have this question, hey, exactly, so are you sure there's no performance side effect on the switches when we collect all these metrics, like millions of metrics? And the answer is no, there's no performance side effect. Why? Because this is the architecture. The ASICs, the 32 gig fiber channel ASIC, these are custom designed fiber channel ASIC we design internally in Cisco. They have the hardware tap. They tap into every packet that passes through the port at line rate without any performance side effect, and because this capability is part of the ASIC, the software doesn't get involved. After that, the ASIC strip of the headers or make a copy of the headers, send it to an onboard network processing unit. This is where all the magic happens. This is where, if there's an IO transaction, we tap into the first frame, we tap into the last frame, and we take a time reference and say, this is how long the whole transaction took to complete. But finally, as I said, just collecting the metrics or collecting the data points is not going to solve the problem, right? So that is where we export the metrics to an external anything. It can be anything. From Cisco, we have SAN Insights. We have a partnership with a company called Virtual Instruments. Now they renamed themselves to Vertana. That is another solution, but yeah, it can be anything. I've seen customers using Splunk. Yes, you can use that. Right? The export mechanism is an open format, and that's what enables it. So this is the architecture of 32 gig, and that's what we did in 2017. But now, in fact, last year, we launched 64 gig fiber channel, and the analytics architecture on 64 gig fiber channel is a bit different. And I mean, there's a lot of changes. We don't have to go inside all of that. The simple changes in 32 gig architecture, we have the traffic inspection on the ASIC and the metric calculation on the NPU. Now, what we did on 64 gig is we moved the metric calculation logic as well on the ASIC. So ASIC does both the things. Now, how does it really matter? What's the benefit of this? There are 4 big benefits. Number 1, if you analyze how many IOPS you can run on 48 ports of a 64 gig fiber channel module, the theoretical number goes to more than 1 billion IO operations per second. And guess what? On 64 gig, you can analyze all of them. That's just the 48 port. In a switch, depending on how many slots you can have more modules there. So multiply that number by 1 billion IOPS, and with 64 gig, you can get visibility in all of them. That's number 1. The second point is the NPU is still there. Now, the benefit of NPU is that it's software programmable. If, let's say, we want to add newer metrics, especially fields like NVMe, they are still evolving. Let's say 2 years down, they come up with something new, and we want to add a new metric to report performance on that. We can do that because we have a programmable NPU. Right? Third benefit, there are additional metrics. Briefly, I'll talk about that, but again, that's a detailed topic, better suited for a 2-day training, right? But there are additional metrics. And finally, a lesser known fact that we have a 1 gig telemetry port on the module itself. Now, the reason for that is really we want to provide investment protection to our customers because Look, hardware purchase is a longer cycle. I'm sure you guys see that too, right? But let's say in the future, I talked about those 3 million metrics that we can export every 30 seconds. I've heard from few customers, not many. They say, no, 30 seconds is too long. I want every second. And then we realize, if you want to send data every second, the management port may not be enough, right? May not be enough. And by the way, MDS is a fiber channel switch, so you cannot have a front panel port like you have on Nexus or Catalyst. You cannot have an Ethernet port on the switch. So for that reason, we added a dedicated telemetry port on the module itself, right? Now, it's not enabled today. It's not enabled because we don't need that. But let's say 2 years down the line, if we need that, then a new hardware churn is very expensive for us. It's very expensive for you, right? So that's why it has the port, not enabled today, but if it's needed, when it's needed, it will be a software-only upgrade. Okay? All right. So how do you enable SAN analytics? Well, for those of you who have not tried enabling it, trust me, it's super easy. In fact, it's so easy that, when you make things so easy, then you realize, hey, you know what, you missed all the checks and balances, you just enabled it. And I talked to so many customers, they said, yeah, it was so easy to enable it, we followed a 5-step wizard, we enabled it. It's like, no, you got to design it first. Right? It's network. You just don't do enable commands. Just because it's easy to enable it, you got to design it, right? So before you enable it, or let's say before your teammates or anybody else that you come across enable it, for that knowledge, be aware there are 3 high-level deployment models. Because the capability is part of the ASIC, you can actually enable it anywhere. It can be enabled on the ports that are connected to a servers, the host ports. The I/O transactions are received there. We tap into there and report the metrics. Or you can enable it on ISL ports, or you can do on your storage ports, right? I have the storage ports on the left, host ports on the right. So yeah. Now, that's flexible. When there's flexibility, the next question is, OK, just tell me one, right? Which one should I pick? So look, there are some pros and cons. What you get with storage ports, it's something you are closer to storage, so your performance numbers match what you see on your storage arrays. When you're closer to host, your performance number matches closer to your apps, let's say what your Linux reports or what your ESXi reports. But if you really look at last 4 or 5 years, what I'm seeing, what most customers are doing is they're enabling on storage ports. Right? No hard and fast rule, but that's something I've learned too. It gets operationally easier for them to enable on storage ports. Why? Because that's how refresh cycles happen. When they install the new storage arrays, at the same time they're buying the newer hardware, and at the same time they like to enable it. So that's one operational reason that I came across. The second thing is, seems like the hosts are still not being upgraded. There are some hosts that are still running at 8 gig speed, 4 gig speed. They don't want to touch it, right? So, for that reason, they prefer enabling on storage ports. Kind of related to what I said earlier, but, another operational detail. The third factor that I saw is I just mentioned the company Watana, Virtual Instruments. They have a different model where they sell separate hardware taps. And those hardware taps, they install between the storage edge switch and the storage array. Somewhere their hardware taps go here. You see the red line? So when these customers who have been using the Watana hardware taps, they want to enable analytics capability that is fully integrated within the switches, they prefer installing it here, these ports. It's just a comfort zone for them, because that's what they have been doing for 10, 15 years. They like doing the same thing in the future as well. So as you can see, none of these are real technical reasons, but I guess operational details are also more important, not just technical viewpoints, right? Watch out that there's no need to enable analytics on all the ports. There's no need for that. It's the same I/O that starts from the host, goes to the storage arrays, come back. Just inspect it once, right? It's if you enable it everywhere, just too much. Too much information, too much data points, as your scalability goes down for no reason. And I would say 95% of the use cases you can solve by enabling it at a single place. So pick and choose one and stick there. It's easy. Okay?
How long should it run before you have usable data?
Okay, so the question is, how long do you run before you have usable data? On the switch, you have the metrics within a few seconds, like 1 second, 2 seconds. But by the time data reaches DCNM SAN insights or NDFC SAN insights, it takes a few minutes, like 30 minutes, 45 minutes. The product will say, wait 2 hours, right? So somewhere in between. The reason is, the product has an automatic baselining and learning logic. So it receives all the metrics and it starts making a baseline. So it takes a while, right? Okay, so what are the metrics? These are some of the metrics. Like there are 80 plus metrics that are collected per flow. If you look at the way read and write transactions happen over SCSI or NVMe, that's a very simplistic representation, right? And I'm going to talk about this a bit more. But if you look at a write command, it's really a two-step process. The host initiates a write command. It's really called a command frame. It goes to the storage array. The storage array allocates some resources and sends a transfer ready to the host. The host says, all right, now I'm going to send you data that you can go and write on the backend storage. And then finally, when all the data is written to the backend storage, the storage array sends a response. And the total time taken to complete this transaction is called exchange completion time. Or simply it's just called latency. I'm sure if you open let's say Dell EMC's web page or IBM's web page or anybody who makes storage in this world, their web page, they'll say latency under 100 microsecond. And then you ask, what do you mean by latency? That's what they mean by latency, the total IO completion time. It's too much to write on a web page. The web developers won't like that, right? But then that's not the only latency. When the first command frame reaches the storage array, it's taking a while to process it. Maybe it's busy. So it takes a while, and then it sends a transfer ready. So that time that the storage array takes is kind of a severe delay, is what we call as data access latency. In short, DAL. If you use the product SAN insights, you'll see ECT and DAL all over the place. That's what they mean. Technically, that's another type of latency. But you won't see that in a high-level document. And then these are just two metrics, but then, as I said, there are 80 plus metrics. I can't even list that on a single slide without really making the font size really small. I don't want to do that. Just want to focus on what's more important. Also, it's really important that all these metrics are collected at every flow level. And that is the question, okay, what is a flow in Fiber Channel? I'm sure all of us know what a flow in TCP is. There are 5 tuples, right? Like source IP, destination IP, the port number, and the MAC address, and destination MAC. That's make TCP flow very well-defined construct. In Fiber Channel, there's nothing like a well-defined construct of a flow. Here, what we say that if there's a server, it has a HBA port. That's what we call as initiator port. So that makes I. And then there's a storage port that makes target. So that makes T. And then there's a LUN behind the target port. Right? Or in NVMe, it won't be LUN, it's namespace, right? But it's just another name. It's exactly the LUN. And by the way, technically, it's really logical unit. I shouldn't call it as LUN. It's logical unit number. That's what makes LUN. For application owners, it's just a volume. They just see a disk. They see, okay, I received 100 gigs. That's it, 100 GB of storage. They don't know anything about all that. But the flow is really an initiator, a target, and a LUN, and all these metrics are collected at every flow level. Like you can say, tell me the IOPS for an initiator. You'll get the answer from SAN Analytics. Or you can say, no, break it down and tell me the IOPS for an initiator and target transactions. And then you can break it down further. You can say, now show me the IOPS for an initiator, a target, and a LUN flow. Right? So based on your use case, you can actually pick and choose what you want. Because look, not every time you want to go at that detail level. It's just too much information. If you want to know the performance of a host, you stick to initiator flow. If you want to know the performance of an initiated target LUN flow, you pick and choose ITL flow, right? So it's totally flexible from that perspective. All right, so let's get into one more level down and look at 3 metrics, and I'm going to talk more use cases on these 3 metrics. So essentially, I already talked about exchange completion time, which is the total amount time taken to complete an IO transaction. And then data access latency is the delay caused by the storage array. And there's a new metric that's only available on the 64 gig MDS switches. That's what we call as host response latency. That's the delay caused by the host. It's essentially, this delay is HRL, host response latency, while this delay, as you see here, it's DAL. And this entire, as you can see, this thing right from here all the way till here, it's like ECT. These are 3 kind of delays. Now, if you don't want to understand all of it, just remember when an application slows down and somebody believes it's because of storage access issue, you need to focus on your ECT. That's what your latency is. After that, if you want to go next level, remember HRL or host response latency points towards a problem towards the host, not storage array. But if your DL degrades, or if you want to know if there's something wrong with your storage array, you focus on DAL, right? Just remember that. Even if it's, let's say, you're still struggling, like, okay, how does it really make sense? But just remember that for now, right? We'll go into detail. And here is a question for maybe you. Let's say there are 2 hosts, initiator 1 and initiator 2. Initiator 1 says, I have an exchange completion time for read commands that take 400 microseconds to complete. The other initiator says, I take 800 microseconds to complete. Okay, SAN Analytics gives you this information. After looking at this information, what do you believe which server is performing better? Any thoughts, guesses? Yeah, maybe, I don't know. But it's not enough information. The reason is maybe one of the practical examples that happens, if initiator 2s are doing large size read commands, it's going to take longer to finish IOs, transactions, right? Maybe initiator 1 is doing IO size, or IO transaction of size, let's say 4K. Initiator 2 does 128K. Yeah, it's going to take longer, right? So that's why it's not enough information. It just gives you some initial idea. Let's go to the next level. Now I show you a time series view of the same number. I just told you one number. I didn't tell you when is it increased, what happened last week, things like that. Now look at the graphs. Initiator 1 had been doing 400 microseconds of exchange completion time for a week. But now today morning it goes to 800. It's a 100% spike, while initiator 2 stays at 800. Now which one do you believe, which server is into trouble? Initiator 1, right? And this is something like, these are the kind of graphs that you see in SAN Insights. Now let's say somebody complains, somebody raises a ticket saying that, hey, you know what, my application's slow. I believe it's because of storage access issue. You log into the product, you say, hey, you know what, last 7 days, my graph has been straight line. Today morning also it's straight line. Here's the proof, it's not storage access problem. That's a very affirmative data-driven decision that you're going to make there. But let's say if you see the graph on the top where your line goes up, you say, oh yeah, it's a storage problem, let us troubleshoot it. Right now you have data to accept that, or like take the ownership without really pushing it back. Hey, show me data, and you're not going to say that anymore. Okay? And that's when, let's say, your graph goes up, right? Your exchange completion time, your total time taken to complete the IO transaction increases. And now you're trying to find out, okay, where is the problem? Is it the host that's slow, or is it the storage array slow, or is there a congestion within SAN? How do you pinpoint really quickly? So that's when you bring in more metrics, data access latency and host response latency, right? So if the data access latency goes up, when the ECT goes up, it's really a problem within the storage array, something slowing down within storage array. So you do not focus on SAN anymore, you do not focus on host anymore, you focus on your storage arrays. But let's say if you look at the graph below, where data access latency is a straight line, that means the storage array is sending the first response really fast. Nothing changed there. But your total I/O time still changed. So is the host response latency taking long? Maybe. If you see a graph spiking like that, the answer is yes, and that's when you focus on your host. Because remember, it's quite complicated block I/O stack within the host itself. If you look at like Linux stack, there's 7 layers from which a block I/O command passes. If you're running virtualized, then the whole stack duplicates, right? A VM and then the hypervisor. So very much possible something slowing down there. But if you use data points like these, it takes a few minutes to plot these graphs and like, see this happening and yeah, move it forward from there. Okay, so this is the flow chart I just talked about. You start from ECT. Somebody complains, I have an application performance problem. You look at ECT, exchange completion times, as a total amount of time. If you do not see a change, with data, you can say not a storage access problem. If ECT increases, however, then you go and look at your DAL value, HRL values. Is it a SAN problem? Is it a host problem? Is it a storage array problem? And accordingly, you move forward, right? Those graphs, you're going to have those graphs in the slides. You can take a look at them exactly the same way you can plot it in SAN insights, right? And see if there are spikes like that. Okay. Now let's talk about the real world problems. Like these are I'm going to talk about 4 case studies now. That's where I want to focus more. These are the problems that I personally worked with customers, like different scenarios, probably somebody reached out or like, and I thought if those customers can run into those problems and could have solved them, maybe it can help you as well, right? So this is something happened at like a Spanish bank. I was delivering the same 2-day training there. And in that training, they enabled it. They're sitting in the room, the whole storage team, and they saw a graph like this on one of the servers, right? Because one of these storage admins, he always suspected one of the servers, so he took that and plotted. And without any prior knowledge, if you look at this graph, what does it tell you? A couple of things. Number one, something happens every 10 minutes, right? You have a timestamp. Second thing, this is the graph of exchange completion time. Remember, when exchange completion time increases, it's bad. I mean, may not be really bad, but I don't like that, right? I want to finish my I/O transactions in 200 microseconds, not in 400 microseconds, right? Lower the better. So it increases, then it dips, and then straight line. If I take a guess, sounds like somebody's holding onto the I/Os and then suddenly open the floodgates and all the I/Os get completed and stabilizes, okay? So this is first level information. We saw that and said like, all right, as part of training, let's try to solve the problem, if we can solve the problem. So what we did, after ECT, we plotted the graph for write DAL. Remember, DAL is the delay caused by the storage array. And we don't see anything here. Seems like storage array is doing okay. So that helps me to exclude storage array. Now the problem can be within the network or it can be within the host. Next level, we plotted the same graphs for read commands. Now, if the network is a problem, it's going to equally affect both the write and read transactions because the network doesn't know. For the network, it's just like frames. It doesn't know what transaction it is. And we don't see anything interesting in read commands. And by the way, if you're wondering, these are like, I draw these graphs because obviously there's no way I could have taken the real captures, right? So this is coming out of my memory, right? Yeah, it wouldn't be nice for me to take capture and like show it publicly. So these were the graphs that they saw. So when you see no effect on read commands, it kind of tells me it's not a network problem. And then we ran the slow drain analysis. That's something, I'm going to talk tomorrow, 8 a.m. Really a feature that, detects congestion. And we didn't see anything there. So after all this, all the fingers were like, all the data points were pointing towards host. So what we did is, because I was sitting in their office, the manager of the storage team called his peer, the manager of the compute team, and say, hey, we see something like that. And the guy says, yeah, let me find whose application runs on the server. So they found there's a Oracle app that runs on the server. So Luckily, they happened to call that application owner. Yeah, and he saw that graph and said, yeah, you know what, I don't know much what you're showing, but that 10-minute thing, he said that a couple of months earlier, there was an Oracle bug that they ended up patching on all the servers. And they said, if you still see that 10-minute frequency, probably it's one of the servers on which they forgot to patch. It's like, okay, so now you're saying the storage team, the infrastructure team is telling an application team that you forgot to patch a server, right? And that whole exercise took 45 minutes to find. And what the storage team manager told me is that it has never happened in the history where the infrastructure team has told application team anything to do. It's always the other way around. It's always these guys complaining and telling me what to do. But with all these data points, it was made possible to detect an unpatched server, which kind of slipped without being detected earlier. Right? So this is the power of using the latency metrics, which can be exchange completion time, data access latency, and host response latency. Now, by the way, when I was running this training, there was no host response latency because host response latency, which is the delay of the host, is really new. It's very new. It came up in 64 gig hardware. I don't think anybody has that, right? So I wonder, had this been host response latency back in the days, it's really quick. Then it's even more quicker, right? Okay, so that's one case study. Let's talk about the next one. So now we haven't really talked about congestion in SAN. That's what I'm going to talk tomorrow, 8 a.m., but without really going into all the details. There's a specific kind of congestion that we say that, which really happens in speed mismatch. Let's say an all-flash array is sending a large size read traffic to host that's connected at a slower speed. Because the link is overutilized, and because these are lossless fabrics, there's no dropping the frames. Something that happens over Ethernet TCP, right? If, let's say, you have a switch, 100 gig incoming, 10 gig outgoing, the switch is going to drop the packet after a while, right? The buffers will run out. In lossless networks, such as like Fiber Channel, there's no dropping the frames. In fact, what happens, there's a link-level B2B flow control mechanism. That's what we use and slow down the sender. And because of that, there's a congestion happens, right? So in this case, this host, that really is connected, it's causing congestion because that link that's connected to it, it's like almost fully utilized, and it's virtualized. So the question is, how do we know which VM is causing that? Right? Obviously, you can find the answer or go log into vCenter, like spend an hour maybe and like figure out. But that's a kind of very reactive approach because you have to know everything. And a lot of times, these might be different teams, different people. At least that's what a lot of customers tell me. Yeah, it takes like 6 months to get access to vCenter in read-only mode. I'm not sure whether you guys are in the same bucket, but yeah, it still requires working with vCenter, but let's see how SAN Analytics can help you to do that. By the way, this approach a lot of customers use. Okay, so look, understand on a storage network, if there's traffic going towards host, what is that traffic? What's under the frames? It's really the read traffic because the host says, I want to read data. And the storage array says, here's your data, and it starts sending at really fast speed. If it's write traffic, really those frames are going towards the storage array in other direction. Those frames are going from the host towards the storage arrays. Right? So when that link, host 1 link, is overutilized, it's really caused by a lot of read I/O throughput, not write I/O throughput. That's one thing to understand. The second thing is there's something called a VEID capability. Not sure if you guys have heard. It's really standard-based approach. It's quite new. Using that approach, the network comes to know about the virtual entity. It could be a VM, or it could be a container. Really a futuristic thing. I don't believe anybody has that today. So most customers are in the second bucket where they have the visibility of an ITL flow. So use that. Use the second option that I have and get a breakdown of which LAN is sending the most traffic. Once you have that information, maybe if you have access to vCenter, or if you don't, go and talk to the person who has access to vCenter. Tell them, I'm seeing congestion in the network because of this LUN. Show me which data store is created out of it and which VM created a vDisk out of that data store. It takes 30 seconds, right? That like, you log in, like you go to configure tab, and configure tab, you look at storage devices, it's going to show you. Maybe I have a screenshot right next. And you can actually pinpoint on the VM that's causing congestion on the network. And once you know, I mean, that's what I see. Once the problem is understood to a lot of customers that I work with, I don't have to tell them how to solve it. They know how to solve it. Like everybody has their own operational practices. Somebody likes moving somewhere else. Somebody likes adding more capacity to the link. Somebody has more HBAs. And yeah, solution is easy if the problem is understood, right? And here, if a lot of these customers start with that, there's an alert that comes that says, hey, your link is congested. And if they can find which VM caused that, then they can do something about that, really solve it. Okay, so these are the screenshots, right? So let me zoom here. Something like this is what you see on SAN Insights. It's the top 10 devices as per the read IO throughput. It's ready-made, you don't have to do anything. Just enable it, and this is something going to be ready-made available. After that, let's say if you pick and choose devices, something like this, if you focus on this read throughput, if you are, I'm sure you are unable to read from there because I was unable to read from there. In this column, you get to see the read IO throughput and the write IO throughput of all your hosts. If you have 1,000 hosts, you're going to see a list like that for all those thousands of hosts. And if you click on them, you're going to see a visual like this. It shows you a network path, like SAN A, SAN B, multipathing working. And then it's going to show you if your multipathing is working well, how much throughput is coming from where. Also, you can go and plot a time series graph. There's a tab there that says table. Click on that. In the table, you'll see the LUN ID. I've put an orange circle around it. Take the LUN ID, go to vCenter, and a view like this shows you LUN ID. It shows you the data store. You see the data store here on this column. You click on the data store, figure out which VM has the vDisk sitting on the data store. You have the VM that's causing the congestion in your network. Probably it's going to take 10 minutes to find that answer. Not the first time, right? Not the first time, but eventually when you start using this approach. A lot of customers use this today. Sure.
I'm wondering how to identify the congested link, or that the link is congested.
So the question is, how to identify the congested link? The answer will be tomorrow, 8 a.m. There's a whole session on that, right? How do you identify and prevent SAN congestion? Simply, there are features that generate alert, right? There's extremely strong capability to detect congestion and prevent congestion, a feature called dynamic ingress rate limiting, DIRL, with alerting. I'm going to talk all about that tomorrow morning, 8. Okay, another use case. This is something, university in the Midwest. Those people reached out, say that, simple, with almost nothing. They said, hey, you know what, my link is congested. I want to know something about it. It's like, that's a really open-ended question, right? I don't know where to start. It's your environment. But that's how they reached out. Guess what? When we dig, start looking inside it, obviously, over a storage array network, mostly we have like SAN A, SAN B, where a host has 2 connections going to the network. So when we look at their IO throughput, we realized something like this, that one of the network link is congested, is overutilized, while the rest of the network link is underutilized. And obviously, you have the capacity. It's something like you have 2 freeway systems, everybody's going on one freeway system, and nobody's going on the other freeway system. And obviously, the first one is obviously going to get congested. Just move the traffic there. Probably tell people, hey, use the other one. It's exactly like that, right? Just that knowing this whole visual, something like what you see on the screenshot on the right. Let me zoom into that. Just getting to see a visual where you get to see connections from the host and then a breakdown of I/O throughput of all the paths individually. The moment you get to see that, trust me, the problem's solved. After that, you guys can do whatever you want to do with that, right? There are 5 different ways to solve that. But knowing this information, it's kind of like messed up with that way, but there's a throughput column, and the throughput column tells you I/O throughput per path. And in this output, the throughput on fab B is around 10 megabytes per second. And the throughput on fab A is around 1 megabytes per second. 10 times difference. When there's a spike, the spike on fab B happens 10 times more than the spike on fab A. And that's when congestion happens. Once they saw this visual, they went and worked on the MPIO, the multi-pathing software on the host, and yeah, fixed that. And after that, both the links were kind of uniformly balanced. When the spike happens, both of them spike to 70%, right? Which is okay. No congestion at 70%. But if one happens at like 100% spike, the other one spikes to like 30%, that's when the problem is. Okay? Next case study. And this is again like related to what I'm going to talk tomorrow. Now I end up thinking probably that tomorrow's session should have been today and today's session should have been tomorrow. But tomorrow I'm going to talk about, and a lot of times customers ask this question, hey, how do you predict SAN congestion? Yeah, we can detect it. You can prevent it, but how do you predict it? And you can use SAN analytics metrics to predict SAN congestion. And this is a real case study from a large trading platform. For those of you who do share trading, maybe you have accounts there. But here is a problem. They said that, hey, we got thousands of ports, we deployed all flash arrays, and we are running into congestion. And my answer was, yeah, upgrade your host connectivity and say, yeah, just go away, because that's not going to happen overnight. And I'm yet to see a network where upgrades happen overnight, right? It takes years, it takes months, there's no funding, there are no resources. So essentially what this customer was asking, is there a way you can help us to plan in an intelligent way so that we upgrade the devices that are problematic, right? Where is the probability, what ports are likely to get congested before the rest of the ports or rest of the servers, right? Among thousands of such ports, it's a big problem to solve. And this is where it gets interesting, because look at this simple example, right? Let's not talk about thousands of ports that happened with that customer. In this simple example, let's say there are 6 servers that are connected at 8 gig. There's an all-flash array sending read IO transactions at 32 gig. What do you think, which server is more likely to get congested? Maybe all of them, maybe none of them. It really depends on the IO traffic profile of that server. There's no magic to, just to say anything. And that IO traffic details you can get from SAN Analytics, especially focus on the IO size. Because look, not sure if you guys have realized that or seen that. I've seen a lot of networks where the ingress congestion, or let's say server, in this example, let's say server 1, it's very much possible it has the egress utilization of less than 1%, but the ingress utilization is 100%. Because remember, how is the ingress utilization on that server? It's all the read traffic coming back. Why is the read traffic coming back? Because the server sent the read IO command in the first place. And those read IO commands are really small. They're like less than 50 bytes frame. If you put the analyzer, try to take the size of the frame, it's 50, 60 bytes, 70 bytes, that's it. And if that 70 byte frame carries a request to read 5112K data, or like 4 MB read command, it's going to get lots and lots of frames coming back. All full size, 2112 bytes. Right? So what does it tell us? If you focus on IO size, the larger the IO size is, the more is the probability of data coming back. So if you can find the IO size of all these 6 servers, make a sorted list, and if the server 1 says your IO size, your read command IO size is 4 megs, while server 6 says my read IO size is like 5 and 12 bytes, then the probability of server 1 getting congested is more than server 6. That's what is the predictive nature. I'm not talking about any fancy AI, ML, no. It's very simple stuff. There are metrics that can tell us a lot. So that customer did the same thing. It took them a while. Then when they upgraded the storage arrays, they also enabled SAN analytics on the storage ports. Then they collected the IO size. They actually looked at the peak values, because remember, peak values are really important. A lot of applications that I see for monitoring or for visibility, they really show the average. Trust me, you don't see anything in average. You see all good things in average. You don't want to know about good things. You want to know bad things, right? And peak shows you bad things. So focus on peak. They looked at the peak IO sizes, made a sorted list, and they started upgrading from the top. And trust me, the number of congestion issues that they were able to reduce because of this informed upgrade path was huge. I work with a lot of customers. I compared them and I compared rest. There's a big difference, right? Because, yeah, I think it took them 14 months to upgrade everything. Probably it's the same with you guys. It's never upgrade is really not fast. But if you get insights, okay, what you should upgrade first, then just going randomly, it just like pays well. Okay? So yeah, I just want to summarize the 4 use cases. I hope something like this, you can use it too. One is like a European bank that was able to use the latency metrics, the ECT, the DAL, to find an unpatched server. Another, like many organizations, when the links are congested, they are able to pinpoint on a specific VM. I talked about a Midwest university that really, I still remember that email. The email said, hey, a Cisco rep, he wrote it, hey, my customer is seeing some kind of congestion. Can you help? It's like, okay, that's an open-ended question, but it's really turned out like it took an hour to figure out, hey, yeah, show me the data, let's keep looking. And then we found that misbalance and fixed that MPIO to solve the congestion problem. And then the 4th case study, I talked about a large trading company that was able to plan a better upgrade scheme using the predictive capability of SAN Insights.